Hello and welcome to this new series about multivariable calculus. This will be a video course where I explain things concerning functions defined on Rn. For example, we will talk a lot about derivatives like partial derivatives, directional derivatives, and total derivatives. However, before we start with this, I really want to thank all the nice people who make such new video courses like this possible. And there, please don't forget, if you support me on Steady, you get access to the PDF versions and quizzes for all the videos. Speaking of other videos, I can tell you it will be helpful that first you watch my real analysis course. Simply because there we discuss the normal calculus in one variable. In other words, multivariable calculus will extend this series here. However, of course you don't need to understand everything in real analysis to start with this multivariable calculus course. Moreover, soon you will notice that we will extend a lot of notions from one variable here to several variables there. And exactly for this reason, also my linear algebra course can help you there. This is what you will understand immediately when we write down functions from Rn to Rm. In the linear algebra course, such functions would be linear functions. However, here in multivariable calculus, we will consider a lot of different functions from Rn to Rm. But still, we will ask if we can approximate these functions with linear functions. Which, as you might know from the one variable case, leads to the notion of derivatives. Moreover, you also know such derivatives can help finding maxima and minima of functions. And now with this course, we will be able to do this for quantities of interest that depend on several factors. And indeed, you will see we have a lot of applications for this. In addition, this course now can help you to understand my more advanced courses. Indeed, quite fitting after this will be my manifolds course. And also, functional analysis will generalize a lot of topics from here. And lastly, I can tell you, if you know how to deal with multivariable calculus, you also know how to deal with complex analysis. So in some sense, here you can use a lot of facts for functions from R2 into R2. Okay, now I think we can talk a little bit about the topics you can expect here. First, we start very simple and talk about continuous functions. So we will extend the definition of continuity that we learned in real analysis. Then, in a similar sense, we will generalize the notion of a derivative from one variable. However, it turns out there are a lot of different possibilities for that, and therefore we will talk about partial derivatives, directional derivatives, and total derivatives. Indeed, we will see all of these notions will be important for us. Moreover, by using these things here, we can generalize an important theorem from real analysis, namely Taylor's theorem. So I would say this is a very important fact, but also the most important fact for multivariable calculus will be the implicit function theorem. In fact, this is a result that is used in a lot of applications. And in a similar way, the next one here is also used a lot. It's the famous method of Lagrange multipliers. Okay, there we have it. This is the overview of the course, and we start in the next video with continuity. Therefore, I would say let's meet there and have a nice day. Bye.